I, on behalf of State Council of Science, Technology and Environment, would welcome you, all my dear viewers, especially my dear students of class 10, to this online class. Today, I will be delivering a talk on the second chapter of the class 10 syllabus, MBOSE, which is polynomials. Okay, so today we are talking about polynomials. Now in class 9, we have already looked at the basic concepts of polynomial. So what is a polynomial? It is an algebraic expression which contains four components. I have the coefficients or constants, I have the variables, I have the operators, and I have a positive integer power. So keep this thing in mind. The power that I am using in here should be positive integer. So basically, what are the components of a polynomial? In a polynomial, I will have constant terms which are real numbers, then I have variables. Now my variables are the values which can change in the operation. I usually denote variables by in the English alphabets X, Y or Z. And then I have various operators used in here. So I have operators. What are my operators? We all know what operators are. These are basically the addition, subtraction, multiplication, division that we use in an algebraic expression. And I have a positive integer power. Positive integer power. So basically, if an algebraic expression contains these four components, it becomes a polynomial. Now a question arises, if an algebraic expression contains some of these components but they are missing with some, does it become a polynomial? The answer is yes. Let us take an example. Suppose I have a number. Suppose I have a number 1. Now is this a polynomial? The answer is yes. Why? Although you cannot see any variable in here, I am not seeing any operations in here, and also there is no positive power. But this we all know by the laws of exponent that anything to the power 0 is equal to 1. So I can write x to the power 0 is equal to 1. Now we know that if I have a 1 in here, I can replace this as 1 into 1. This one I can replace this as 1 into x to the power 0. So basically this is x to the power 0. So you notice one thing in here, I have a variable, I have some constant terms in here, and also there is an operation. And this variable contains a positive integer in here. So these are the conditions that it should satisfy to form a polynomial. Let us look at some examples of polynomial. So my polynomial, I can have polynomials as this. I can have x, I can have x squared plus x, or I can have x cubed plus suppose 1. Now in all these cases, you notice I have a variable, I have some operator in here, I have some constant terms, like in this case I have 1. Even in here, although I do not have anything before x, I can replace, I can introduce a 1 in here. So basically I have some constant terms in here also. So these three expressions, algebraic expression becomes a polynomial. Okay, let us go further ahead. Suppose I am taking this expression. I have x plus x to the power minus 1. Is this a polynomial? Now this expression I can also write this as x plus 1 by x. So my question is this a polynomial? The answer is no. Why? Because although there is an operator, I have some constant terms, but the power in here, I have a negative power in here. I have minus 1 which is negative. So this is not a polynomial. Keep this in mind. Again, let us take another example. Suppose I have x plus root of x. This expression I can write this as I have x plus instead of root x, I can replace this by x to the power half. So again, let us see. Do I have constants in here? Yes, I have constants. I have one in here. Do I have variables in here? I have variables, and also I have an operator. But are the powers of x a positive integer? The power in here is 1, but the power in here is half, which is not an integer. So this is also not a polynomial. So just keep these two things in mind, that if in an expression I have a negative power or a power which is fractional, these two expressions is not a polynomial. So there may be questions asked, objective type of questions asked, which they will give you a polynomial asking you to state whether it is a they'll give you an expression asking you to state whether it is a polynomial or not. So this is the introduction of polynomials. So I am again explaining what is a polynomial. It is nothing but an algebraic expression containing four components: the constant terms or the coefficients, which are usually real numbers. Then I have variables. What are variables? These are values which can change in the operation. Then I have operators. Operators are your plus, minus, multiplication, division. And the powers of the variables should be positive. So if an expression satisfies these four, or it has these four components, it becomes a polynomial. In a polynomial, I should not have anything else other than these four components. So now, in your class 9, you have learned about this. I may have polynomials as this. I may have x squared plus x plus 1. Or I may also have x squared plus y squared plus 1. See, this is also a polynomial, this is also a polynomial. In this case, I have a polynomial with only one variable. And in this case, I have a polynomial, I have two variables in here. Okay? So, in this chapter, in class 10, we will be mainly focusing on polynomials with a single variable. We'll learn about how to solve these polynomials, what are the zeros of polynomials and all. So now, let us look what do we mean by a degree of a polynomial. So in the first example that I took, I have given you these three polynomials. I have x squared plus x, and then I took this x squared plus 1. But in this case, suppose let me take, I have x cubed plus x squared plus x plus some constant term, suppose 5. So I have three polynomials in here. First of all, I should understand whether these expressions are polynomials or not. In this case, these are polynomials. So what do we mean by degree of a polynomial? As we can look, in some cases I have only one term. In some cases I have two. In some cases I may have more than two terms. So basically, for a degree of polynomial, I am looking at each term and I am looking at the power of the variable in these terms. So let us look at this. What is the power of the first term? The power of the first term is 3. What is the power of the second term? This is 2. The power, although I do not have anything in here, it means that it is 1. So although I do not have any power in here, it means it is 1. So I have a 1 in here. Again, as I told you, 5, although there is nothing in here, I can introduce x to the power 0. Keep in mind, x to the power 0 is 1, so 5 can be written as 5x to the power 0. So you notice the thing in here. For different terms, I have different powers, and in here, what is the maximum power? The maximum power is 3. So I say the degree of this polynomial is 3. So the degree of this polynomial is 3. So basically, how do we define a degree, or what is a degree? It is the highest power of the terms present in a polynomial. So that is a degree of a polynomial. Now depending, like in this case, I have two terms. For the first term the power is 2, for this term the power is 2, for this term the power is 1. So what is the degree in this case? The degree is 2. So the degree in this polynomial is 2. For the first one, I have only one term, and what is the degree in this polynomial, or the power of this variable? It is 1, so the degree of this polynomial is 1. So from here, I have three other important polynomials. The first case, where the degree is 1, is said to be a linear polynomial. If my degree is 1, The polynomial is said to be a linear polynomial. Linear polynomial. So keep this in mind. What is a linear polynomial? It simply means the degree of the polynomial is 1. If the degree is 2, I say that this polynomial is a quadratic polynomial. So this is a quadratic polynomial. And if the degree is 3, it is known as a cubic polynomial. So this becomes a cubic polynomial. If the degree is 4, we say it to be biquadratic polynomial. So from here, let us see what these polynomials are. So for the first polynomial, what type of polynomial it is? It is a linear polynomial. This polynomial is a linear polynomial. The second polynomial is a quadratic polynomial. Why quadratic? Because the degree or the highest power of this polynomial is 2. So this is a quadratic polynomial. And the third polynomial, that is this polynomial, is a cubic polynomial. Why a cubic polynomial? Because the degree is 3. So this is how I classify polynomials in terms of degrees. Now, apart from these polynomials, there are two other important polynomials. The first is your zero polynomial. I mean your constant polynomial. What is a constant polynomial? As I told you, if I have a number 5, is this a polynomial? The answer is yes. Why it is a polynomial? Because 5 can be written as 5x to the power 0. So these type of polynomials is known as your constant polynomials. Now what is the degree in this case? The degree in this case is 0. It has a 0 degree. Degree is 0. Again, I have another polynomial which is known as your zero polynomial. So what is a zero polynomial? Basically, if I have this real number 0, this I call it as zero polynomial. Now, question that arises in our mind. We have all looked at different degrees of different polynomials. What is a degree of a zero polynomial? This is an important question. Now, 0 in how this becomes a polynomial, because I may have into x to the power n. Now n, it can be any natural number, it can be 1, 2, it can be anything. So what is the degree of the zero polynomial? It can be anything. As I told you, it can be anything. I may have 1, I may have 2, I may have 100, I may have 10,000. It can be anything. So basically, the degree of a polynomial is not defined. We do not know exactly what the degree of a zero polynomial is. So keep this in mind. If someone asks you what is the degree of a zero polynomial, we do not know. It is not defined. Now, having learned about all these polynomials, let us learn how do we represent a polynomial. So how do we represent a polynomial? Suppose I have a polynomial with degree with a variable x. So this polynomial I represent in this way. I have p of x. This is equal to, suppose I have a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on. So basically this is the representation in general of a polynomial. What I have a polynomial with variable x, so I write this as p x. This is equal to a naught xn, a1 x to the power n minus 1 plus a2 x to the power n minus 2, and it goes on. So see, what are the things I have in here? All these letters that I am using, like your a1, a2, a1, a2, a0, all these are my constants. That means I know these values in an expression. These values will be given, and this value n, these are your natural numbers. It may be 1, it may be 2, it may be 3, depending on which I'll get different types of polynomial. So this is the representation of polynomials in general. Okay, let us we have learned about polynomials. let us understand why do we need these polynomials in our day-to-day life, or why is it included in our syllabus. Now, if we look at math, especially in this mensuration portion, there are many formulas which are full of polynomials. All these formulas that we use, these are polynomials. Like for example, if I give you a square with side A, what is the area of a square? It is a square, which is a polynomial. So basically, I have polynomials. I have to use polynomials in our day-to-day lives for various formulas that we need to apply. Okay, let us take another example. Suppose, just an example. Suppose you have appeared in an exam and there is a condition given to you. The condition is this: if you get X marks in exam, that means the marks obtained by you, if this is X. Suppose your brother will give you 2X chocolates. Your mother will give you suppose X squared number of chocolates, and your father will be giving you suppose X cubed number of chocolates. So at the end of the day, how many chocolates are you receiving? How many chocolates are you receiving? You'll get 2X plus X squared plus X cubed. Will be receiving this many, you'll be receiving this many amount of chocolates. So what is this? This is a polynomial. And what is the degree? The degree is 3. So we can understand in this way, like in our day-to-day life, there are many uses of polynomials. Now, okay, let us like use this example again. So this, how will I represent this? I write this as P of X. This is equal to this much. Suppose in your exam you got suppose 20 marks. So I have P of 20. So what will you do? Since you got 20 marks, you'll be receiving 2 into 20 amount of chocolates from your brother. So what I am doing, I am replacing the value of X in here. So I have 2 into 20. You'll be receiving 20 squared number of chocolates from your mother. So I have 20 to the power 2 plus I have 20 to the power 3. This will be giving me some value. So why I am I took this example. See, in here I have a general polynomial, and from this general polynomial I am particularizing the value of X. That means I am putting a particular value of X. In this case I am putting 20. So this particular value that I will be obtaining, this is known as the value of the polynomial at X is equal to 20. So this, the value that I will get in here, this is the value of the polynomial X, of the polynomial Px, and X is equal to 20. So I hope this is clear. This is very important. What do you understand by value of a polynomial? Simply, if they give me some value of X, I simply replace X by that value. The value that I get, that will be the value of the polynomial at that particular value of X. Okay, let us generalize this. Suppose I have a polynomial. Suppose I have this polynomial. Let us take this ax squared plus bx plus c. I am taking a quadratic polynomial. You can take a biquadratic, anything, cubic or a linear polynomial. Now, what will be the value? The value of x, of px, the value of px at x is equal to, suppose I am taking a number which is alpha. So what will be the value of polynomial at x is equal to alpha? I have p, instead of x I replace with alpha, and I will do the same in this case in here also. So I have a, instead of x I replace the value with alpha, plus b, again I have alpha, plus c. So this is the value of the polynomial px at a value x is equal to alpha. Okay, again with this I have another important concept. Zeros of a polynomial. What we understand by zeros of a polynomial? This is very important. See, as we look in here, I can put different values of alpha, and correspondingly I'll get different values of this polynomial px. Now what if I put such a value of x in here so that this polynomial will give me a zero polynomial? What I mean, if I'm putting, like when I put x is equal to alpha such that my p of x becomes equal to 0, a zero polynomial, then this value of alpha is said to be the zero of the polynomial. Okay, so keep this thing in mind. If I have a polynomial given to me, and then if I am required to find out the zeros of the polynomial, what do I mean by this is that I put such a value of x so that this polynomial will give me a zero polynomial. Okay, so earlier we looked at how to find values of polynomials. So basically, if I put different values of x in a polynomial, I'll get different values of the polynomial. Now using these values, I can plot graphs of this polynomial. So let us look how will a graph of a polynomial look like. Now for a constant polynomial, okay, before this, in general, suppose if I have a polynomial such as this, suppose I have a naught x to the power n plus a1 x to the power n minus 1 and continues. What I do to plot the graph of this polynomial, I replace px by y. So my first step is that I'll do this. I'll replace my px by y. Now in class 9, we learned a basic about how to draw, how to plot points in a graph. Okay, let us look how will the different polynomials behave in a graph. So for a constant polynomial, how does my constant polynomial looks like? I have suppose p of x, this is equal to some constant term, so I am assuming this term to be a. So what I have done in there, I will do in here. So I have y, this is equal to a. How does this graph look like? This graph will look something like this. It is a line which is parallel to the x-axis, and this line is at a distance of a units from the x-axis. So the distance between this line which is parallel from the x-axis, it is a units. Let us look at an example. Suppose I have taken my polynomial, suppose it is p of x, suppose it is equal to 3. So I replace p of x by y, so y is equal to 3. So how will my graph look like? We know how to assign points in here. So I have something like this, 1, 2, 3. I have 1, 2, 3, 1, 2, 3. So this is my 1, 2 and 3. This particular, the graph of this particular polynomial will be a straight line which is parallel to the x-axis, and it is at a distance of 3 units from the x-axis. So keep this in mind. For constant polynomials, the graph of the polynomial will be parallel to the axis. What about the linear polynomial? So let us take an example. Suppose I am taking this example. I have p of x, this is equal to, suppose ax plus b. Now the graph of this polynomial will be something like this. It will be a line, it will be a straight line, but it will make some angle with the axis. It is making some angle with the axis. In this case, this line was parallel. In this case, the line was parallel. But in this case, the line the graph of this polynomial will make some angle with the axis. Now what about a quadratic polynomial? The equation of a quadratic polynomial, if I take this polynomial, I have p of x, this is equal to suppose ax square plus bx plus c. Now we understand that this is a quadratic polynomial. So how will the graph look like? It will look something like this. So this is a graph obtained when I plot the points of a quadratic polynomial. Now this type of figure, this is known as a parabola. This is known as a parabola. So these are the graphs that I will obtain if I plot different different polynomials in the graph paper. Okay, so earlier we have looked at how different polynomials behave in a graph. Now let us look how we get this different graphs for polynomials. So for simplicity's sake, I am taking a linear polynomial. So linear polynomial, the degree is 1. So let us take an example. So suppose I am taking my polynomial to be p of x. This is equal to, suppose, x plus 1. Okay. Now, as I told you in like earlier, what I will do, I will replace p of x by y. So y is equal to x plus 1. Now, whenever we draw a graph, we must understand, or the first step that we should do is tabulate different values that I will get when I replace x with different values. What I mean to say is that when I put x, different values of x, correspondingly I will get different values of y. So first I need to tabulate this. So suppose I am taking my x to be equal to 1. So if I name this as equation 1, from equation 1, I have my y is equal to, instead of x I am putting 1, so I have 1 plus 1, so which is equal to 2. Okay. Now if I change the value of x to, suppose, minus 1 now. So from equation 1, I have my y, this is equal to minus 1, instead of x I am putting minus 1. So I have minus 1 plus 1, which is equal to 0. Okay, let me take the third value. Suppose I am taking x to be equal to, suppose in this case, suppose minus 2. So from equation 1, I have my y is equal to minus 2 plus 1. When I solve this, what I get? I get minus 1. Okay, now these values I need to represent this in a tabular form. So how to do so? My tabulation will look like this. See, I have three values of x and y. So I have three values of x and y. For the first case, when x is 1, so suppose I am putting the values of x in here, the values of y in here. When the value of x is 1, what is the value of y? It is 2. So when the value of x is 1, the value of y is 2. When the value of x is minus 1, the value of y is 0. So when the value of x is minus 1, the value of y is 0. And when the value of x is minus 2, the value of y is minus 1. So when the value of x is minus 2, the value of y is minus 1. Now this I will plot there. These values I will plot in the graph. So for the first point, I have x is equal to 1, y is equal to 2. So at x is equal to 1, I go 2 units up. So I have a point in here. I hope you understand. Again I am telling you, x is 1, so x is 1 in here. X is 1 in here, y is 2. So for y is equal to 2, I have to go 2 units up. So this is my point. For the second one, I have x is equal to minus 1 and y is 0. Where is y 0? In the x-axis. So x is equal to 1, y is equal to 0. This will be this point in here. And the third point that I have is x is equal to minus 2, y is equal to minus 1. So minus 1, that means I have to come down. So x is equal to minus 2, y is equal to minus 1. I have this point in here. Now when I join this, you see, when I join this, I am getting a straight line. If you do properly with a scale in a graph paper, in a proper graph paper, you see that this is a straight line. So whenever I have a linear equation, always I am getting a straight line. Now, a very important concept that I can get from here is this. We have already learned what the zeros of a polynomial are. What are the zeros of a polynomial? These are values of x which will give me the polynomial to be equal to 0. So these are values of x which will make my polynomial to be equal to 0. So in this case, which is such a value that makes my polynomial equal to 0? So if I put if I put my x is equal to minus 1, I am getting my p of minus 1. This is equal to minus 1 plus 1, which is equal to 0. So my polynomial, or the 0 of this polynomial, is minus 1. Let us look from graph. Is it saying so? You see in here, when x is equal to minus 1, my y is equal to 0. So when x is equal to minus 1, my y is equal to 0. And what was y? Y, it was the polynomial. I replaced px by y. So y was the polynomial. So from graph, what can I say? When I plot the graph of a polynomial, the point at which the graph intersects the x-axis, that value of x gives me the 0 of a polynomial. So in this case, the 0 of the polynomial from graph is minus 1. Why? Because this line, it intersects the x-axis at this point. And in this point, the value of x is 1. Okay?